In this video, I'm going to cover rectilinear motion for beginner calculus. So let us suppose we are given an equation for our displacement. And displacement pretty much tracks the position of a body at any time t. The value for displacement, the function for it, is given by the letter x. So x of some function given by time would represent your displacement. Okay, so I'll write it down. This is equal to displacement. Okay, if I want to work out how fast is my body moving over time, so I know the position, but what I'm really interested in is how fast is it moving relative to time. That's the same thing as the derivative of time. That's the same thing as the rate of change of my position with respect to time. So if I work out the derivative, dx on dt, okay, this is another way for saying it's analogous for, say, meters squared per second. Okay, meters per second. Meters is your position units, and time is your seconds unit. And you know meters per second is really just the same as velocity. So if you want to work out your velocity, given your displacement function, simply just differentiate it and you arrive at velocity. Now, if you want to work out the rate of change of velocity, okay, according to this flowchart, the rate of change of velocity is really just the same as acceleration. So that means the derivative of velocity with respect to time is equal to acceleration. And another way of saying that is the double derivative of displacement. So the double derivative of displacement with respect to time, when you differentiate this twice, that'll equal to acceleration. Now let's suppose you want to go backwards, you want to go the other way. So let's say I'm given my acceleration, but now I want to work out my velocity. So what I can do instead is I can simply anti-differentiate or just integrate my acceleration. So if I integrate my acceleration function with respect to the variable of time, I will get velocity. And I can do the same thing with velocity to go backwards to displacement. I can just integrate my velocity function with respect to time, and I'll simply get the displacement function. So this is the basics of rectilinear motion, and it's called rectilinear motion because you are moving in a simple path left and right. You are not moving in a pendulum motion, you are not moving in a 3D space motion, you are simply just moving left and right across a body. So let us work out some problems using this concept. So this is the first question here. So the position of any body, right, when we alter the time is given by this equation. And we know this is a quadratic. So the position of any body over time is modeled by this value here. So if x was equal to, say, 3, that means 3 units away from the origin is the displacement. So the displacement or the change in position from the origin is 3. Find the initial velocity of this body. Well, to work out the velocity given the displacement, we would simply need to work out what is the derivative of our displacement. So what we're going to do is we're simply just going to differentiate this original equation. So the velocity equation is simply the derivative of displacement with respect to time. And that's the same thing as 2t take 12. So if you want to work out the initial velocity, we can say that it will be the same as when v equals 0, or v of t when t is 0. So v of 0 is 2 times 0 take 12, and that's simply just 12. And the units for velocity will always be something like meters squared per second. So in the question they didn't say it, but x is in meters. Okay, so x meters. So that means meters per second. Meters per second is your rate of change of your displacement. So 12 meters per second is the initial velocity at time equals 0. The next one is when does the velocity equal to 0? So if we want to work out when the velocity equals to 0, we simply need to work out when is our derivative for displacement equal to 0. Okay, so what we can do is we already have the velocity function. Velocity function is v of t equals to 2t take 12. So now we need to work out when is this equal to 0. So 0 equals to 2t take 12. That means t is simply equal to 6. So at 6 seconds, after 6 seconds, the body will not be moving left or right, up or down. It is stationary. The velocity is equal to 0. This is a stationary point. But the question also asks where. Okay, so we're asking what is the displacement? What is the position when x equals to 6? So we worked out the time when the position doesn't change. The time when velocity is 0 is 6 seconds. Now we need to work out the position at that place. The position when x equals 6. When t equals 6. So all we do is we plug it back into this original equation here. So we can say that it's the same as 6 squared minus 12 times 6 plus 11. So when we work this out, we get 36 minus 72 plus 11. That's the same as minus 36 plus 11, which is the same as minus 25. So minus 25 meters is the position when t equals to 6. Now we need to work out, it's minus 25. Didn't I write that? Now we need to work out the average velocity for the first 3 seconds. They're not asking for the instantaneous velocity. Okay, if they say instantaneous, that means we need to use derivatives. They're just asking for the average. To work out the average velocity between 2 points, okay, we have 2 types of velocities or 2 types of values. Anything instantaneous, and anything average. If we want to work out the instantaneous rate of change, what we can do is simply work out the derivative, dx on dt. That'll tell you the derivative or the value for the velocity at a point. But if you want to work out the average between 2 points, right, so between A and B, and maybe the velocity was super high, maybe it sped up really quick, and then over time you started slowing down, but you just want the average between 2 points. You don't really care about what the velocity was at any given point in time. What we can actually do for the average is we can do the position in the final position minus the initial position divided by the time it took to travel the 2. So B take A. And B and A are the times. Okay, so if you want to work out the average velocity between the first 3 seconds, what you can do is you can work out the final position after 3 seconds and minus the initial position and simply divide it by 3 seconds, because the distance traveled divided by 3 is the average distance traveled per second. So let us now work that out. Okay, it's a bit small, but working with what we've got. So the final position is simply going to be x of 3. So we can work out x of 3 by simply subbing it into here. That's the same as 3 squared take 12 times 3 plus 11, which is just 9 minus 36 plus 11. So that would simply be minus 16. So we know x of 3 is minus 16. Now we need to minus away the initial position, and we know the initial position in our equation is simply just going to be 11 because it's a quadratic, and that means it's the y-intercept. So is it minus 11? No, it's plus 11. And then we can divide it by 3 because we want it over the first 3 seconds. And this value here is simply just going to be minus 27 over 3, which means it's minus 9 meters per second. Because you're traveling average between points A and B in the first 3 seconds in the negative direction by 9 meters per second. So that's how you work out the average velocity. What about the average speed in the first 3 seconds? Well, for those of you that don't know what the difference between speed and velocity is, velocity is a vector quantity. Velocity is a vector quantity. And what that really means is velocity has both a direction as well as a magnitude. So the answer to the part C that we just did, we knew that we're traveling 9 meters per second. So that would be our magnitude. But this negative entails we are going in the negative direction. So if we assume that we have an x-axis, this is your positive direction, this is your negative direction. The negative 9 gives you the direction that you're going in this direction by 9 meters per second. But for speed, you don't really care in which direction you're going to. If you were to ask someone how fast they traveled on the highway, no one really tells you that you're going 100 kilometers per hour north. Okay, no one really says north, south, east, west, negative 100 kilometers per hour. You would simply just give the speed of 100 kilometers per hour. So if you want this number here, just this number of how fast you're moving per hour, that would be equal to your speed. So in other words, to work out the speed, okay, to work out the speed of anything, it's simply the same as the absolute value of the velocity. Okay, so in this case, because the velocity was minus 9 meters per second squared, on just meters per second, we can say that the speed was just 9 meters per second. We don't really care about the negative. Okay, this is our next question. So we're given the displacement is given by this cubic equation for when time is greater than 0. And we need to work out what is the velocity when time is 0 and what is the acceleration when the time is 0. So what we would do here is we would simply need to work out first what is the velocity and acceleration equations. So to work out the velocity equation, it's simply the same as the derivative of your displacement. So if we differentiate our displacement, we get our velocity equation. So when we do that, we get 12t squared minus 12t. And to work out our acceleration equation, a of t, we can simply just differentiate the velocity, so dv on dt. And what we get when we do this is 24t minus 12. But the question specifically asks, what is the velocity when time equals 0, and what is the acceleration when time equals 0? So we can simply just sub in 0 into this equation and this equation. When we sub 0 into this equation here, we get that time is simply going to equal to, we get the velocity is simply going to equal to 0. And the acceleration when time is 0, if we sub this t equals to 0 here, is going to be minus 12. And for the purpose of this question, time is in seconds and position is in meters. So the velocity when time equals 0 is 0 meters per second, and the acceleration is 0 meters per second squared. So that's how you do part A. Now part B says, find the t, values of time, for when the body is at rest. So the body is at rest when the velocity is equal to 0. So when v of t equals to 0. So what we're going to do is we're simply going to let this equation equal to 0 and solve for the value of t. So 12t squared take 12t. And if we wanted to solve this, we can say that 0 equals to 12t, and we can factorize a t and a minus 1. So using the null factor law, we can say either t must be equal to 0 or t take 1 must be equal to 0. In which case t is simply equal to 1. So now that we have the times for which the body is at rest, we need to work out both the position and the acceleration at those times. So let us first work out what is the position at these times. So what is both x of 0 and x of 1. So when we sub into our original equation 0, okay, so 0 here and 0 here, these terms simply cancel and we're left with 5. So the position is 5 meters. And when x equals to 1, we get, we can sub in 1 into here to get 4 minus 6 plus 5. And that's the same thing as 3 meters. So now we have the position at those times. Let's work out the velocity, the acceleration at those times. So the initial acceleration, we need our acceleration equation first. This is our acceleration equation. When we make t equal to 0, okay, we simply get this crossed out and we get minus 12. So minus 12 meters per second squared. And we also get, when we make a equal to 1, okay, we get 24 minus 12, which is simply just 12 meters per second squared. So this is the acceleration and position at these times here. Okay, this is our next question here. So we have been told that the position of a body is given by this equation here, and I've given the units as meters, and time is going to be in seconds. So now that we have this, work out when the velocity of the function is going to equal to 0. So first, let us simply find the derivative of our displacement. So the derivative of displacement is simply going to be the velocity. So when we work that out, we get 2t take 7. And we want this equation to equal to 0. So 0 equals to 2t take 7. So t is simply equal to 7 on 2 seconds. Okay, or in other words, it's simply just going to equal to 3.5 seconds. Next, find the acceleration at this time in part B. So if we want to work out the acceleration at this time, we first need to work out the acceleration equation. So the acceleration is simply the double derivative of our displacement, or simply just dv on dt, the derivative of our velocity equation. So when we do that, we get the acceleration is going to equal to 2. So what this means is the acceleration, no matter what time we given, is always going to equal to 2 meters per second squared. Okay, so we can use any time we want, but at any time it'll always equal to 2 because there's no variable where the acceleration actually changes. Next question. Find the distance traveled by the body in the first 5 seconds. So the distance traveled, you can do it one of two ways. Okay, that's simply just equal to the final distance minus the initial distance divided by, just the final distance minus the initial distance. So let's work that out. So when x equals to 5, okay, so x of 5, we get 5 squared minus 7 times 5 plus 10. So 5 squared is 25 minus 35 plus 10. So that would be equal to 0. So we can do 0 minus the position when time equals 0. So 0 squared take 7 times 0 plus 10 is simply just going to equal to 10. Okay, so that means we get 10 meters, more in this case, negative 10 meters. But you'd notice that that's actually incorrect because the distance that we travel is not the same as the displacement of my body. So let me draw a little diagram to visualize this. So we start when time equals to 0 and we end when time equals to 5. But this is a quadratic, right? So wouldn't that mean that you actually have a change of direction halfway through, somewhere in between? So you can go in a certain direction, but then come back in the exact same direction. And in this case, what we've been told is simply the change in the initial and final position. So we have been told the distance of just this distance here. But you can clearly see that the body actually travels a distance. It travels some distance here and some distance here, but we haven't accounted for any of this. So here's what we do. We work out the initial times and the final times. So we're told in the first 5 seconds. In the first 5 seconds, yep, so t equals 0, t equals 5. So now what we do is we need to recognize where our stationary points are. When is velocity equal to 0? Velocity is equal to 0 when t equals 3.5. So I'm simply going to do another dot in between. T equals 3.5. And I'm going to write the displacements at each of these times here. So when t equals to 0, we're at minus 10 meters. When t equals to 3.5, we need to work that out. So let's work out what the displacement is. So what is x of 7 over 2? When we do this, we get 7 over 2 squared minus 7 times 7 over 2 plus 10. And I don't have a calculator handy, so let's do it by hand. So we get 49 over 4 minus 49 over 2 plus 10. These two here are simply just the same as minus 49 over 4 plus 10, and plus 10 is the same as plus 40 on 4. So this is the same as minus 9 on 4 meters. So we can say the displacement here is minus 9 on 4 meters. And then where the displacement when t equals 5 is simply 0. Okay, so we have worked out the displacement at each of these key points. So what is the distance traveled from minus 10, in this case it should be 10 meters. So the initial displacement was actually 10 meters. So what was the distance traveled between 10 meters and minus 9.4 meters? Well, that would be simple. That would just be the same as minus 9 on 4 minus 10. And this is the same as just minus 9 on 4 minus 40 on 4. So the distance traveled between these 2 points here, if I do it in a different color, is simply just going to be minus 40 on 4. So now what is the distance traveled from minus 9 on 4 to 0? Well, the distance here is simply going to be 9 on 4 meters. But I don't really care about direction. If I'm asking for distance traveled, okay, the negative means has no value to me, because all I care about is the absolute distance traveled from here to here. So in this case, what we would actually have is we would get 49 on 4 here. So that is the total distance traveled from here to here. And then the distance traveled from here to here is 9 on 4. So that means the total distance is just these two added together. Okay, so the total distance traveled between these 2 points is simply just 49 on 4 plus 9 on 4. And that's equal to 58 on 4 meters. The last part is the average velocity traveled in the first second. So to work out the average velocity in the first second, what we can do is we can simply do the displacement when t equals 1 minus the displacement when t equals 0 divided by 1 minus 0. So what we get when we do this is we can sum in x equals to 1 first, so t equals to 1. So 1 minus 7 plus 10. Okay, that's the same as minus 6 plus 10, which is just minus 4. Minus the position when x equals 0 is 10, all over 1. So that means your average velocity in the first second is minus 14 meters per second. And that's how you do rectilinear motion with derivatives in this video.